Hi everyone. I'm Professor Bali Starry from the Chemistry Department. I'm Dr. Liang Xue, teaching Organic Chemistry at the Pacific. Welcome to our lecture. Welcome. First of all, we'd like to acknowledge all those who helped us making this lecture possible. Of course, the University of the Pacific. Within that, we're most grateful to Athletics, the Division of External Relations who funded us, Media Relations who got the word out, Department of Chemistry who got all the chemicals for us, who is within the College of the Pacific. We're also grateful to the Formal Connection and most grateful to you guys for showing up here and being interested in science. Okay, tonight's experiments include three things. First, we are going to look at colorful experiments. What we want to do is we just want to show you how colors can be a very fun tool in chemistry. Second, we're going to look at some of the very classical experiments in chemistry. And third, I guess, here are the moments everyone's waiting for: explosions and combustion. Okay, now let's look into the colorful experiments. The first experiment I will show you is called a chemistry rainbow. So what I'm going to do now is, in front of me I have, thank you, heavy precautions for the safety. Alright, in front of me I have 6 empty beakers. What I'm going to do now is I'm going to pour this colorless solution into these beakers. Now each beaker will give us a distinct color. Putting together, we will have a set of the rainbow color. Now let me show you first. So from the left to right, the colors will be red, orange, yellow, blue, green, and violet. Okay, now I will pour the colorless solution into these beakers. What color is this? Red. Let's take a look at this one. Orange. What is this? Yellow. Blue. Green. And then we have violet. Okay. Thanks, violet. Okay, now let's go with this color again. I have red, right? It's pretty red. Well, orange probably is a little bit similar to the red, but let me see. This is actually a little bit orange than red. Okay. Now we have yellow, green, and blue and violet. Now, of course, this is amazing, right? But the question for a scientist is always want to ask the question, why? Here's the scientific background. Okay. In fact, I cheated. I told you these are empty beakers, but they are not. Before the lecture, I had several drops of a special chemical called pH indicators into each beaker. Now what the pH indicators do is these are chemicals that change color under the acidic or basic conditions. Okay? The color solution is not really water. Actually, this is a sodium hydroxide solution considered a strong base. So I chose 6 pH indicators, which gives a distinct color in the presence of the strong base. And this color happens to be a set of the rainbow color. Now this is called a chemistry rainbow. Now of course these chemicals are very unique, expensive, you can only get it from a chemistry lab. What I'm going to do next, I would like to show you a trick to make a pH indicator in your kitchen. In fact, there are lots of vegetables and foods contain natural pH indicators. For example, red cabbage, okay? Grapes, roses, probably strawberry. But today I'm going to show you how to make a natural fusion indicator from red cabbage. I want to ask you a question for you. We always use red cabbage. Do you know why? Anyone? We always use red cabbage. Do you know why? What? Well, yes, that's a very good answer, but this is not the question I'm looking for. This is why we are always using red cabbage. Very good. This is one of the reasons it's cheap. Okay? Well, of course, the reason is red cabbage probably is give the best results considering the grapes or roses. So let me show you how to do it. I need to bring a couple of issues to the table. Where's my red cabbage? That's a good question. You take it? Very good. What you need to do first is you take a red cabbage, cut it into smaller pieces. Okay, now you put the red cabbage into a blender. Okay? Next, just add water. We'll have some distilled water here. Okay. Next, what you need to do is simply just fry it for about a minute. Okay? Let's try it. Well, I can you hold it? Thank you. I think it's here. Thanks. Right. Next. So what we need to do next is we just filter the mixture through a sieve and get the red cabbage juice. You can also use a little bit of fresh water to bring the residue on the top, just trying to get more red cabbage juice out of it. Now the red cabbage juice is ready, and we are for test. Because you can get a red cabbage juice from the kitchen, so what I'm going to test is not other chemicals from the chemistry lab. Instead, I'm going to use something you can find at your house. What I have here today is the lemonade, of course, ginger ale, baking soda, household ammonia, vinegar, what is this? Windex. Okay, Now, what you need to do first is you can divide these radioactive juice into small portions, into these small beakers, okay? Thanks, Tom. All right, before we move on for testing, I have something else I want to say. Well, we know the pH indicators can change color on acidic or basic conditions, but as a chemist, I'm really not satisfied with this statement. I want to know a little more. I want to know how acidic the solution is, or how basic the solution is. In fact, in chemistry, we use something called in chemistry, we use something called pH scale. Now, what's the pH scale do? The larger the number, the more basic the solution is. The smaller the number, the more acidic the solution is. I have already did the test before for the radioactive juice. I know at the pH 2, with a pretty strong acidic condition, the radioactive juice shows red. Okay? At the pH 12, big number, basic solution, the radioactive juice gives you green color. Now, in between, there are several other colors, but I never got able to distinguish between the color between purple and violet. But anyway, let's take a look at the test now. Now, what do you want to test first? Lemonade. Okay, what do you think about lemonade? What do you think? Red color. Now, let's go to this table. Okay, I have red color lemonade probably has a pH value between 2 to 4. I consider it acidic, right? So what would be next? We have ginger ale, we have baking soda, Windex, vinegar, ammonia. Windex? All right, what do you think about Windex? Acidic? Basic? Basic? All right, let's do it. What do you think? So it's probably not as red as the lemonade, but it definitely shows the red color. So I would say probably between the red and purple, maybe the pH around 4. How about next one? All right, of course. Well, I don't really see too much color change. What do you think? Probably it's establishing that you have purple color beginning. Now it's slightly purple. So I would say the ginger ale probably not as acidic. It probably is acidic, but it's weak acid, maybe between 4 to 6. Okay? So next one I want to try is let's try something. How about ammonia? What do you think about ammonia? Basic? So let's see. Oh, what's this color? Green. So the household ammonia is strong base. This shows the green color. pH value about 12. Okay, pretty strong stuff. Next one, vinegar. Oh, you love vinegar. Acid, of course. Pretty bad color, right? Well, actually, if you compare vinegar and lemonade, pretty close. Okay, both are very acidic stuff. The last one I want to try is the baking soda. What do you think?
Blue.
What color is this? Clear blue. So, the baking soda probably is not as strong as the ammonia. I would say it's between 8 to 10 to give you blue or green color. So this is how you can make your own radioactive juice a natural pH indicator in your kitchen to test some of the stuff you are interested in in your kitchen. Okay. So next.